Hey guys! Today my presentation is going to go over some of the literature I've read about how socioeconomic status is related to the physical structure of the brain. I decided to take my research question one step deeper to connect to educational psychology. On top of assessing the relationship of SES and brain structure, I'm also researching how these differences in brain structure could explain variances in academic performance. The topic I chose is difficult to separate from the field of educational psychology. It deals with education because it examines how SES affects students' achievement in the classroom and in standardized tests, but it also deals with psychology because it poses the question, how are these students being affected by elements outside their control, such as SES? This topic is also important because it brings attention to the fact that socioeconomic status is not only directly linked with cognitive ability, but also with physiological development, which is a connection many educators may not realize. Before I dig into the data, here are some important definitions for this presentation. First is socioeconomic status, which is often misinterpreted as household income alone. In actuality, SES is measured by accounting for several other aspects of wealth, including education, occupation, social standing, and class. Next is gray matter volume. This phrase is referring to the tissue in the brain that is made up of neurons and connections between them. The gray matter of the brain is the tissue that stores the most information, and its volume refers to the amount of the tissue present. Hemispheric asymmetry is much like how it sounds. When I use this term, I'm referring to the differences in activity across the left and right hemispheres of the brain. Last on the list of terms is cortical thickness. Cortical thickness is the measurement of the density of the brain, and it's measured by the amount of space between the white matter surface and the peel surface of the brain. Researchers have already documented that low socioeconomic status is correlated with cognitive ability throughout all ages. Of all the abilities that are influenced by SES, language ability is the most affected, followed by executive function, like critical thinking and decision making, and then memory, both working and non. My research question seeks to clarify how these differences in ability might be explained by the anatomical differences in the student's brain. This presentation will summarize what the literature highlights as the three main structural differences in the brain that are correlated with SES. The first is the volume of gray matter in the brain. Keep in mind that gray matter is the tissue that stores the most information and is made up of neurons and glial cells. In one study done in 2012, researchers compared gray matter volumes of high SES and low SES individuals using an MRI scanner. They found significant positive correlations between SES and gray matter volume in the frontal lobe, as well as the left hemisphere of the brain. They also found that the brains of higher SES individuals had more gyrification in these areas. Gyrification increases the overall surface area and allows more information to be stored in the brain. So how does this connect to the achievement of these individuals in the classroom? First, this study found that the participants with high gray matter volumes significantly outperformed participants with lower gray matter volumes in cognitive tests of literacy and verbal ability. Secondly, the brain areas in which the volume and surface area most significantly differed toward the front and to the left are the same areas most responsible for the cognitive abilities of language, executive function, and memory. These are the same three abilities emphasized throughout the literature as being most closely tied to SES. On top of influencing the volume of gray matter in the brain, SES is also documented as affecting the asymmetrical function of the brain's hemispheres. Asymmetrical function simply means that the left and right hemispheres of the brain are functioning at different levels. Although this is not always negative, too much asymmetry has been found to be correlated with poor performance. In one study that has been cited by over 50 other authors, researchers performed an fMRI on each participant to compare levels of function in both the left and right hemispheres. The results painted an interesting picture of how SES can affect the area of the brain known as Broca's area. This region has been nicknamed the brain's script writer because it holds the crucial role of putting our thoughts into words and applying meaning to what we say. This study found that children from low SES families had significantly lower function in this area of their brain than children of higher SES families. In other words, SES was significantly correlated with brain asymmetry in that the frontal lobe function was lower in the left hemisphere than in the right hemisphere. These findings are of interest to educational psychologists because research has shown that in many cases, higher levels of hemispheric asymmetry result in poorer academic performance. More notable, though, is the nature of the asymmetry. Because Broca's area is the critical structure in a person's ability to communicate, an increased asymmetry in this area, that is linked to lower SES, could provide another example of how brain structure influences the student's language ability. The final differences in structure due to SES come from variances in the cortical thickness of the brain. Cortical thickness is defined by how much space is in between the surface of the white matter and the surface of the outer brain, the pial surface. Just this year, researchers in Massachusetts have used MRIs to measure the cortical thickness of adolescents from varying household incomes. Do note that in this study, they're focusing on income as their measurement instead of socioeconomic status. They found that lower income is significantly correlated with lower levels of cortical thickness, not only in the frontal lobe or left hemispheres, but throughout all lobes of the brain and across both of the hemispheres. The higher income participants not only had significantly thicker cortices, but they also outperformed the lower income participants. The adolescents with thicker cortices did significantly better on both the math and the language arts achievement tests. This answers the question, how does cortical thickness relate to performance? The literature highlights that the higher levels of cortical thickness are usually associated with higher test scores and overall general intelligence. My research question is directly related to what we have studied in class in many ways. First, it expands on the section of our text regarding SES and achievement. Woolfolk doesn't give detail about how students' brains are physically different, but she does explain how home environments for lower SES students often do not afford the same learning opportunities as higher SES students. Also, the anatomy of the brain, which is discussed in the earliest chapters of the book, relate to this topic because after learning that language ability is the most lateralized function of the brain, residing mostly in the left hemisphere, it was easier for me to draw connections between structural differences and cognitive performance. Woolfolk's discussion of the physical brain in the opening chapters illustrate to me that anatomy and ability go hand in hand. I first became interested in this topic after learning how SES can influence achievement and wondering if these differences could be connected to the physical brain. In conclusion, the literature supports what we previously learned in class. Lower SES is related to lower academic performance. It also provides possible evidence for why these differences exist and illustrates how SES influences things such as gray matter volumes, hemispheric asymmetries, and varying levels of cortical thickness. If I were to continue with this research, I would love to know the extent to which SES changes the physical brain, and also how these anatomical differences are related to a student's cognitive ability and to what degree. Thanks for watching.